So let's start Google Map system design. Functional requirement. Basically, for the Google Maps, the main important part is to identify the roads and routes, like find a path between point A to point B, because usually users will try to find the path right from the source to destination. So that's the main of the Google Map. Then next is to calculate the distance and the ETA, like how far it is from the source. What is the time it is going to take to reach particular to that destination. Then this map or the system design should be pluggable, because if we need to add any new features, we don't have to change entire whole architecture. So it should be a pluggable. And also this Google Map has to show 2 to 3 different routes options to the user, when user is like, when there is any traffic or something like that, then it should able to show different routes to the user so they can select it. Next thing is traffic and weather conditions. These play an important role, but this cannot consider approach, distance of A to B. This can be considered as attributes, or you can say this can be used as a pluggable functions for, achieving this, identifying the distance between A to B. Then we have something called as new roads. Like suppose in Google Map we do not have those roads, and we identify these new roads with the help of government sources or with the help of user movement data. Then we need to put it in our database and update our Google Map database. Then another thing is, if many people are traveling to same route or same location, which are unknown path or which is unknown location, maybe maybe there is some social event which is going on, then we should detect that as a new road or a new community or a new zone which has to be identified and update our map service jobs. Next, use traffic volume and number of travelers to guess the road type. Like, when you're finding the new roads, you need to know like whether it is a 6-lane road, single lane road, or 4-lane road. So we need to have that detection with the help of the volume of the traffic and the travelers which they are traveling on that route. Then for non-functional requirement, it should be highly available, and it should give fair enough accuracy, I should say. It should not be like, Google Map is showing 20 minutes of distance, but actually it's a 1 hour. So it should not happen like that. It should give you a good or a fair accuracy, and it should not be too slow. And this Google Map is massively used. What I know is monthly 1 billion active users are there. So that means 1 billion active records are created, requests are created for this particular Google Maps. So now let's see, let's get into challenging question of Google Map. Like if there are, if suppose there are 50 to 100 millions of roads, right? If there are these many roads, just take a number, okay, in the entire globe, then how will be out the ETA, and how we will compute that. So roads are completely actually unpredictable, and sudden closures are there, sudden constructions are there. So we have a proper scalable approach and not a absurd approach in this case. So let's see how we can solve this. So solve this question, this challenging question of understanding the gap between 2 points. And because there are so many roads, it's not like we can calculate all the roads immediately. We need to have a scalable approach here. So here comes an approach of something called as dynamic programming. And why dynamic programming? Because we'll solve the first smallest problem and then later on approach the bigger problem. So let's see what are the segments. Suppose this is our map, and now one of the map, take one state or take one city. This is one city, and now you are dividing that city or state into different segments, right? These are the segments. There's something called segmentation concept which I'll let you know. So these are the segments. Now a city is divided into so many parts. Each segment here has coordinates. So coordinates, for example, it has a coordinate of 0 0 0 1 1 1 1 and 1 0, suppose 1 0 and 1 1, right? Suppose a point lie between over here and the point has 0.4 and 0.5 as a coordinate. So now you know this point is within this particular box. How you come to know? Because you have this latitude longitude coordinates of that box. So this segment will help us to give approach. Like if a point is over here, you might know what is the coordinate of that point, and because of which you will come to know it will lie in this particular segment. Same thing, if a point is over here, you will come, okay, this is 0.9 or 0.10, so this is something which is out of the segment. You will have a proper segment which will match the coordinates of that, and this will help us to calculate, you know this will help us to calculate the ETA. So basically we are trying to solve a problem like to a distance of A to B. How we can calculate that? We are trying to solve. So this is one of the approach that we can do it, like segmentation of that particular map or segmentation of that particular city, so that we understand the coordinates and map the points of those destination and the source, so that we come where the user is basically located, where is the destination located. Each segment has latitude and longitude, so we can quickly calculate the aerial distance, and this can help us to calculate the ETA at the end of the time. Now this approach is only for one city. Now the same approach we need it a bigger scale. So this is for one city, so make sure make it for an entire globe, right? For when you make it for entire globe, you just have to put the entire globe into different segments, and then you just have to think bigger picture. So each globe has this particular coordinate, and now you will be easier for you to tell that if you want to understand a user is located in India and another user is located in US, then how to calculate the time and where is the what is the distance of traveling and which all routes he can take, that we can easily mention it. So this is the way we can solve it, like approaching with the help of a segmentation. Now there is something other, like this is one kind of an let's see. Now let's see graph model for the roads, right? A graph model for the roads. When I say graph model for the roads, like a road has this A to B, right? This is suppose A and this is B. So a particular road can be bidirectional. It is always has to be bidirectional. But right now, for the sake of explanation, I'm taking it as non-directional. So make it no, just one way direction and not a bidirectional. Now here we have A to B points. A has weights of 2 kilometer. When I say weights, every road has some weights, 2 kilometer, and suppose it takes 150 seconds of time to reach to. So these are the weights for this particular road. So this can be used as one of the approach to calculate the ETA of reaching the destination. That's one thing. I just wanted to give you an explanation about the roads. Like roads also consist of weights and how we can use that for our approach. Now to find the shortest path between A to B, right? Find the shortest path between A to B. Let's try to take another example here. Let me just give you an example of a different suppose we have this kind of a map. Okay, uh, so we have this kind of a map. Okay? These are the segments which I'm drawing, like these are the, you can say, a junction. Okay, this line is actually going from this particular corner. Okay, now we have A here, I, F, G, you can say E, F, E, D, C and B, and here is D. Okay, so now if you want to reach between if you want to reach from A to B, right, what is the shortest distance you need to find out? So definitely there are different types of route. You can travel from A to B directly, or you can travel from A, I, G, F, E and then B, or you can travel from A, or you can travel another way is A, I and then B. Another way here is A, I, G, F and then going till D and then going to B. So there are different routes over here, right? So how to find the shortest path? One of the algorithm is Dijkstra's algorithm, which you can use it to, you just have to run it on this particular city to find the shortest path and then put it into the cache. Once you put it into the cache, going forward and whenever you are coming back to this particular A to B destination, users, source and destination, and definitely you can take it from cache and give the answer to them. So this is the way we can solve shortest path problem. Or there's one more case in this, right? I mean, I just mentioned that this is the way, but there are different types of routes over here. There can be here one more junction, there can be here one more junction, or there can be here one more point or a junction. Then at that moment of time, how to calculate this particular distance between A to B? For that, let's see how we can do it. So suppose we have this, I'm drawing it little more specifically. Suppose we have this kind of a map, right? And here is A, here is B, right? Here is C and here is D. This is C. And here we have that point, which is a random point and it's not a junction or nothing, but we have this particular point. Now we have to calculate the distance. So what we can do is option one is, calculate the distance between A to X and X to B, right? We have to calculate a shortest distance between A to A to X and X to B. Suppose this is I and this is J. Then calculate the shortest distance between A to C and B to E, basically B to D. Sorry. So once you calculate this distance, you can understand, okay, which is, and you put an or condition. So you have distance, shortest distance of A to C plus I, or you have a shortest distance of B to D plus J. Whatever is the shortest distance will be the shortest path for solving the distance when there are random points in between the roads. I hope you are understanding that. And the same thing applies for exits, because this can be extended to exit E1 and this can be extended to exit E2. For example, we have, this A point is joined to different segment. Here we have an exit, here we have another exit. So now suppose you're checking globally, then actually mega segment, this is one small micro segment, this can be a mega segment. Like you have to calculate this Dijkstra's algorithm for E1 and E2. The same thing applies over here. So once you know the shortest distance between A to B, it becomes easy to calculate E1 and E2 shortest distance. So this is all about the exits. Let's see more thing over here. Explain. Okay, so the thing is, if you have distance A to B, right? If you have the points A to B, right? And you can exactly calculate the aerial distance, that is 10 kilometer, right? Suppose you do not want to use Dijkstra's, then you know the aerial distance is 10 kilometer from somewhere from the cache you have taken. So what you can do is you can increase the buffer from north and south segments. Like, you can add more 10 for now north and more 10 for south, and then run the Dijkstra's algorithm in that part. Otherwise, it will be difficult because if there is a mega segment, then you will have to do Dijkstra's algorithm recursively part, which will be expensive and time taking, and that's not an optimization. So the cache time or the cache distance can be used over here to calculate the shortest distance. So this is something which you can use it from the cache, and that's why cache is always very much important in this case. And the same thing goes for exits. Now, let's see the weights of the, so we didn't spoke on the weights of the roads. Let's see that. Okay. So we have this as a distance, right? We have A and we have B. So that means the weights in weights we need to always calculate is the distance and E. Why we need these two important things? Because to calculate the speed is always calculated, every speed is always distance upon time, right? So this becomes our main weight of the road, and the attributes over here will be traffic and weather. So those are not the weights of the road, those are considered as attributes of the road. Why it is considered? Because if you start adding the traffic over here, you'll have to change the entire logic, you'll have to recalculate the Dijkstra's algorithm of that particular segment, then the main segment, and then the entire globe. So rather than, and always traffic is changing, weathers are changing, so we cannot disturb our main logic of the architecture. So that's the reason we should always have distance and ETA as the main weight of that particular road. And then, you can write the functions for the live traffic updates, or, live traffic updates, or weather. This can be, taken as the functions on top of which these can be impacting the distance and ETA, but it cannot be a wholesome where you have to recalculate the Dijkstra's algorithm. So these are like, you have to write a pluggable functions or the attributes for that particular road. Now let's see the traffic behavior and tier based adjustment. So what is this traffic behavior? Basically, the traffic behavior is something, you know, this can be taken into consideration, like how to quantify the traffic. Like when you are calculating the distance ETA, then you have to quantify this traffic, like how much is the traffic, how bad the traffic is, right? So we always use something called as a tier. And what is this tier? Like tiers are high, low, and medium. So the if traffic is high, that means it is very much bad. So the if in the cache the distance is 500 seconds, right? Then because of traffic, it must have increased to 850 seconds, which is too much, which is very much bad. Suppose the tier of traffic is medium, then from 500 it just reached 550. So we do not have to calculate much over here because it has just increased by 50 seconds, right? So 500 second was the average time earlier taken by that particular distance. So if you see the bell curve of the traffic, right? Suppose this is a bell curve, right? Now here, this is a standard time where every time that person is reaching within 10 minutes, right? Or 500 minutes, 500 seconds, right? Suppose that person is reaching 500 seconds here, 500 seconds, right? Now, because there was a high traffic, it increased the time to 850. Now, this is something we can add here a threshold, so that whenever it increases more than 30%, here we see it has increased like more than 70 to 80%. So if the because of traffic, if it is increasing the time more than 70%, then we have to run it. If it is like, just 550, if it is a medium traffic and it is increased just the 550 seconds of that particular person, then we do not have to run right resolver. This way we can, do the optimization with the help of the tier, and the same logic will be for, weather conditions, whether weather conditions are bad or whether weather conditions are good or fair enough. Something like that we can do it. And this logic will be applied for entire mega segment again, first to the segment, then to the mega segment, then to the entire. Okay, now let's see the main architecture or user location flow. Like when user is online, what will happen, and when user is offline, what will happen. So this flow is very much important, and let's see. So we have this load balancer, basically load balancer. I just mentioned load balancer, but actually you can say that here we have the API gateways and authentication. Then we have WebSocket handler, which is connected to the devices of the user. And then we have something called as a WebSocket manager, which is a repository of devices connections with WebSocket. I hope this we have a couple of times discussed. So let's see, if user is online, right? If user is online and he's in traveling, then he will always ping every 5 seconds. It will always ping his location to the location service. Whenever he's online and he's active in the transit, he's every 5 seconds that location pings are coming, which are then saved in Cassandra. And this is a live update which are coming. Suppose if the user is offline, then it takes 15 minutes or 10 minutes to get the ping to the location service. Okay, that's the main purpose. Location service basically is a service where it maintains, where it takes the, it's a repository of all the user ID versus the location ID of that particular user, and which is saved in the Cassandra. Now, the load balancer persistent connection is maintaining with the help of load balancer. All the user devices are connected properly to the WebSocket handler because of the load balancer. Then WebSocket manager is a repository, as I mentioned, where it connects WebSocket handler, and it does connects the user devices. And the web on top of WebSocket manager we have Redis. So the information is also saved in the Redis cache. If someone asks, if user is pinging that I need to connect, then definitely Redis will come up and will give the details which WebSocket handler is connected to the user one, something like that. Now we have Kafka streaming jobs as well. Let's see how this Kafka is used whenever there are any location events or location pings are happening, right? This will go also to the Kafka. And why will it go to Kafka? Because to detect the unknown routes. So when it, when it uh, pushes the event to Kafka, the thing is, a couple of things will happen. It will be consumed by Spark streaming jobs. So Spark streaming job basically will detect, okay, this is a new road, I need to update this road. Now this will again send a event back to Kafka, which is then given back to map service, because map has to update that we have got a new road. Now once we got a new road, map service will update a graph processing service, which will check the segmentation of each particular where is this road located, what is the segment, what are the coordinates, what are latitude and longitude. All is then checked in and verified and written in the graph processing service, and then it is saved in the Cassandra. This is what is happening when any location is pinged from the user. Another thing is there is something called, it will calculate the average speed as well, like what is the distance or what speed it will, and if there is no update in the map service, it will update that. Another thing is hotspot identifier. Suppose a user mentioned some different road which is not in the map service, then it will definitely update that to Kafka and thus updating the graph processing service. This is what is done. At the same time, Spark streaming job is sending the data to Hadoop. and then it is sending it to Spark ML jobs. Now, why Spark ML job? Because here, whatever new roads you're finding, you'll understand, okay, let's classify this road, whether this is a single lane road or a six lane road. The vehicle where which user is traveling, whether this is a four-wheeler vehicle or a two-wheeler vehicle. So all these machine learning predictions are taken in the Spark ML jobs. Main important thing is over here traffic update. So whenever user is in the route and it is pinging the locations every 5 seconds, and suppose there is a traffic which is observed, then this event is also sent to Kafka. That the traffic update is also sent to Kafka, which is then given to Spark Streaming Jobs, and it will also check the traffic, and thus it will update the Kafka back again that this is the traffic which is observed over here, which is then updated back to the traffic service job, that this is a spot where we have observed the traffic for the further analysis. So this is all about user navigation during when it's live, how the location is getting pinged, and how our Kafka and Spark Streaming jobs are working of it. Now let's see what the in the navigation service, like when we are navigating or when we are tracking the navigation, what is the flow for that? So first thing is user search the navigation or user search the place. That request is given to the area service. So area service handles it with the help of Elasticsearch. Like for example, if a person or a user making any wrong mistake in writing name of that destination, then with the help of fuzzy search and Elasticsearch, area service will understand, okay, this is the location, and now the area service will convert the address into latitude and longitude and return the destination coordinates, which are then given to the uh, uh, navigation tracking flow. Now let's see how that navigation tracking is done. So this request is given to the navigation path that we need this navigation. If the main job of navigation tracking is, once it will show you the distance, right, it will show you the distance, and once if the user is deviating from that particular path, it will mention it to that particular user on the mobile that you are deviating from this route. So let's take another route. These kind of navigations are done by the navigation track, and all the updates or all small details are saved in the Cassandra, like live roads, live traffic are saved on the Cassandra through navigation traffic. Now, main routing service is, routing service flow is from A to B. Like we need to understand like how this routing is happening. So main service is this map service. So once the map service, this map service actually act as an interface layer between both between the user and between the locations which are given. So usually this does not have any logic. It is just for rate limiting purpose and does not have logic, but the map service will give these coordinates and latitude longitude to the graph service. Now graph service will play an important role because it will ask segmentation service to get the segment that particular location. If the results are present in the redis, it will take it from redis and push it back to the map service, and thus push it back to the user navigation. If there is nothing into the redis, it will also check in the historical data. Okay, earlier it was taking 15 minutes of time between A to B. So okay, now let's see how much time it can take it. So it will basically run the Dijkstra's algorithm with the help of historical data, with the help of Redis data, and with the help of segment service, and then come with some logic, some calculation, which is then saved in Cassandra and then given back basically to the user, that this is the time which will be taken to reach from A to B. So from map service, it will again go back to navigation tracking. It will go back again to the area service, and then the routing is done back to the user. This is the way we calculate the shortest distance. Now, how about this is over here? We have Kafka level. This is a Kafka level. Now, every search of a user, right? Search of a user is actually being pinged the Kafka. It is always given to the Kafka, though it is given to the map service. Every search is given to map service to check the segmentation. Map service will give it to graph processing to do the Dijkstra's algorithm, but all the events are also going to Kafka. So here, why it is coming up? Because there are a lot of things which are happening here. First thing is it will check the heavy traffic. There are traffic consumer over here. It will go and traffic consumers. It will, so it will first, this will be uh, consumed by the traffic topic, and the traffic topic is consumed by the third party accuracy. So the third party accuracy will check, okay, this is the traffic over here, and this is a very high traffic, or this is very small traffic. Now the third party accuracy service is actually to check whether the third party is saying correct or wrong. So for this, how we are checking whether third party is giving the correct data or not? So how, what we are doing is we'll check our historical data, like what was the traffic earlier mentioned, and then we'll check is third party giving the accurate traffic, and then we'll check the live updates from the navigation tracking, and thus calculate, okay, this is a correct or wrong third party person who is giving us this traffic update. This is done by this third party accuracy job. So basically every ping which is happening, we are also checking the third party accuracy is correct or not. Then it is also consumed by the Spark streaming, which is then given to the Hadoop and then to the Spark cluster. Basically, this is given for, you know, this is basically given, the Spark streaming jobs. What will it do is it will detect the current road, it will detect the current avenue, and and even that audio which comes on the phone, usually that you are at the fifth avenue and you are, this much is the distance, turn right. So that audio is also, captured by the Spark streaming and the Spark cluster jobs. So that's all about the it's just a brief idea which I have given and tried to explain my best. Thank you.